Alright, let's begin. So for this week's assignment, we had to do the tier collision with the terrain. So as see here, I have a frigate. If it's not colliding, if its B-sphere is not colliding, it's not rendering. If I were to get close enough for the actual collision volume to collide with it, then we will have a debug console message to showcase the collision is occurring. So as you can see right there. Then also, if I were to go off of the terrain, we can see we still do not crash. So I do have edge cases still. No leaks. So all scenes now you can define an active terrain as well as doing the setting the collision pair with the terrain if you have any. So this will end up taking the collidable group and creating a dispatch for the terrain that will pass in a collide terrain function call. And this is what the frigate is using to show the debug message for when they are colliding. Beyond that, within the scene, we now have a terrain manager. This terrain manager has a null terrain in it in case the user never defines a terrain, as well as some setting the terrain and some getters such as getting the nearest point and the nearest normal. Beyond that, this is also responsible for updating, or not updating, drawing the current active terrain. So instead of making the terrain a drawable, I just had it so that the terrain manager renders the terrain. Since there's only going to be one terrain active, I didn't see a need to make it drawable. Or more specifically, the terrain's never going to have any use of draw 2D or anything beyond just the default render. So I just kept it as that. Within the terrain manager now, whenever you want to load something in, you can pass in the height map, length of the terrain, maximum altitude, any offset it has for the Y value, the texture name, as well as any repeating along the U and V axes, and then it creates a terrain given all of that. So here it is being called in load resources. With the collision of the within the test itself, we now have we get the active terrain, and we will loop through all of the all of the cells that are overlapped in it. It will loop through all of those cells, get the AABB of that cell, test the B sphere to that cell. If that passes, then we do the intended collision test. If that passes, we send the collision through the dispatch. This terrain overlap is defined using the current collidable B sphere's minimum and maximum AABB points. We get the starting row and ending row based on those min and max points, and then we set the ending iterator location to be that starting column it found, and then use it the ending row +1. This is so that we can loop through the entire rectangle, and once we get to that next row that we passed outside the rectangle, we can then break out. That sets the ending location for it. And then beyond that, we also have the iterators for this. So I glossed over it real quick, but we start at the beginning, and then we go until we reach the end. So this ++ call over here, nope, not over here, but over here is where we get the beginning and ending of it. This ++, we end up incrementing the column of the given iterator. If we ever reach the ending column, we go back to the start and then increment the row. If at any point, once we do that, we get the cell at that index. If we ever find a row or a column that is going to go if that is considered out of bounds, we set this breakout boolean to true, and that helps us inside our conditional testing, where if we are ever testing something, we know we're out of bounds, so we can just break out immediately. Beyond that, though, we check to see if our row and column is equal to the given terrain's iterator's row and column. If those are equal, we break out. If we're out of bounds, we also break out. That is it for the terrain. The next step is the tank demo. So for the tank demo, I had to redo how I did sounds. Before I had them at the scene level, I ended up moving them to the engine level to fix some issues I had with trying to stop sounds or adjust their volume. So now the sound effect manager, instead of storing the sound effect wrapper class I made, it will instead store sound sources from Erlang. So it will now this thing only takes in the file path, and it will create a sound source using that file path if it does not exist already. And then getting to the same. Because it's now at engine level, we have a activation and deactivation of it done at the engine level, as well as an update call during the update stage. We update it before the scene updates, just in case the scene swaps, and then this has some, because if this had any active things within its requests. If the scene swap, this might end up crashing it. Beyond that, within the actual play itself, when we activate it, this is where we create the sound engine. We have a function to set the volume for the bass engine itself, as well as ways to mute and unmute it. Playing the sound effects will put them into their associated queue for playing and stopping, and then execute requests loops through all the start and stop queues and plays or stops them. When we call deactivate, we drop the sound engine so that client can delete it. Within the actual sound effect wrapper class, now it uses alias sources instead of the source from file. These alias sources have their own ID value that I increment every time a new wrapper is created. And this helps prevent the issue I have, because this will ensure there are no duplicates. And when there are no duplicates, this will never be null. And that means that we don't get crashes when we try and play from null sources. Beyond that, you can set the volume of a source as well as play a sound effect, play it as looping, or just stopping it. And this also stopping all of source. By doing all of these unique aliases, this stop all sounds of source will not stop the sounds of other objects. So now everything is localized to the specific object. Lastly, for UI design, the main change that I had was back-end things, but I did also find a way to make it so that you can have different user-defined button types. So, and also with all these groupings, if the button size is not the same as other buttons, it does not have any weird offsets. Everything is still aligned perfectly. So for that, I ended up doing something similar to what we did with our cameras, where there's now a default up and default down instead of just having an current up and current down. So now whenever the user wants to define their own button down and button up, they will set it. They will call the set function, and that will set that down and up to be appropriate based on what they passed in. And now the button itself will only delete the default up and down. So the user, similar to with the cameras, the user is responsible for deleting any assets they change within the button. Beyond that, I ended up adding a processing of elements for the UIManager. So all of the inputtable checks that the UI components were doing, it is now localized to the UIManager. So this also frees up all of the mouse inputtable functions for the users to define if they so choose. On top of that, how it works is similar to what the the inputtable does, where it gets the mouse cursor's position, gets the current state of the left mouse, and then it will pass through all of its active canvases what the current state is, as well as the mouse's position. So all of the canvases will loop through their current components and pass in the checking conditional based on if it's a press, if it's a down, or if it's a release. So now UI components, whenever you submit entry with this component, you now have to pass in the canvas pointer that it is associated with, so that it can get its proper call through this update loop. On top of that, by moving these things from inputtable, I can also add the final keyword so that the users can't mess with these internals. So now I know that users can't. This will always work as intended, and the users can't change that. Lastly, to talk about the proposal documents. For the tank demo, all of the sound manager is completed. So next up, I have to do the mouse inputs, so that whenever the player moves the mouse, it will update where the tank barrel is pointing rather than using Q&E. And then for the personal project, with all of the back end officially finished, I am now ready for the next week, which is merging everything with the tank demo. And that's it.